everyone's staying safe and healthy. I hope you're washing your hands and not touching your face. We have a new topic today. We're going to talk about simplifying rational expressions. First of all, let me define what a rational expression is. It is a fraction where the numerator and denominator are polynomials. Now, we defined what polynomials were in an earlier video. So if you have a question as to what a polynomial is, check my video on dividing polynomials, and I define what a polynomial is there. So let me show you some examples of rational expressions. One example is just a fraction, 3/4. That is a rational expression. A number can still be a polynomial with an exponent of 0. So these are still considered rational expressions. But when you're really thinking about rational expressions, you're probably thinking of something like x over x plus 5, okay? Here is a polynomial with an exponent of 1. Same thing here, I have an exponent of 1. Let's go a little bit deeper. Let's say I have x squared minus 2x plus 1, and we put that over 3x to the third minus 81. Okay, and let's put another polynomial there. Another variable there. Let's say y to the third right here. So this is another rational expression. These are all examples of rational expressions. As you can see, I have a numerator and I have a denominator. In my numerator, I have a polynomial, and in my denominator, I have a polynomial, okay? So let me show you an example of how to reduce a fraction. Before we can talk about simplifying rational expressions, I need to show you how to reduce a fraction. So here's a quick example. So let's recall how to reduce a fraction. Okay, so let's say I have 8 over 12. I need to factor the 8 and the 12. So I'm going to rewrite 8 as, so we're going to put an equal sign to show that this is the same thing. We're just rewriting it. It's going to be 2 times 4. That's 8. 2 times 4 is 8. Over, and then 12 is 3 times 4. We have a common factor of 4. Now, if you recall from an earlier video, the inverse property of multiplication says if I have a fraction with the same number on the numerator as the denominator, that reduces to just 1. So this 4 over 4 reduces to just 1, and 1 times 2 over 3 is the same thing as 2 over 3. So this reduces to 2 over 3. Well, what about doing this with a polynomial number that has variables? So in example 1, I'm going to show you how to reduce a fraction that has variables as part of their polynomial component. Okay, so we're going to look at example 1. Ooh, I misspelled example. There we go, example 1. And we have 2x minus 3y. And we're going to put that over 3y minus 2x. Now, notice I have the same numbers in the numerator as in the denominator, the same terms. I have 2x and I have negative 2x here. I have negative 3y and positive 3y here, but the signs are all different. So one thing I can do is I can rewrite the denominator. So I'm going to rewrite the numerator. I'm going to say 2x minus 3y, no change there. But in the denominator, I'm going to use the commutative property, and we're going to rewrite these. We're going to say negative 2x and then a positive 3y. Okay? That's going to line them up. And now I'm going to factor the negative out. I'm going to factor out a negative 1 in the denominator. So we're going to say 2x minus 3y in the numerator, no change. But in the denominator, we're going to factor out a negative. So we're going to put negative, open parentheses. And then to take out the negative here, that's just going to be a positive 2x. A positive 3y, if I factor out a negative, that's going to change it to a negative 3y. Okay? And now, aside from this negative, the numerator and denominator are the same. So I can use the inverse property of multiplication to reduce both of them to 1. So I end up with 1 in the numerator, but negative 1 in the denominator. Well, that just simplifies to negative 1. And that is our rational expression reduce. Okay, so that's our initial definition and example 1. Please watch the next video for example 2 and example 3.